Respected experts, I'm Wu Yuan. Today I'll present my research, Nonlinear Dynamic Relationship between CSI 1000 and CSI 300 Stock Index Futures Basis. Linear models fail to capture market regime switching and threshold asymmetry. This study explores the two bases' nonlinear linkage to reveal transmission rules, supporting theory and real trading. I will cover background, literature, and empirical tests, and welcome your advice. This presentation contains 6 logically connected sections ranging from theoretical discussion to empirical analysis and conclusions. It starts with an introduction explaining research background and goals, followed by a literature review sorting prior studies to identify research gaps and innovations. Next comes basis characteristic analysis, then the nonlinear research model design, core empirical tests, and final conclusions with targeted suggestions. Having outlined the overall framework of the study, we will now move to Chapter 1, Research Overview. This chapter first elaborates on the practical background of the research, identifies core research gaps in the current field, and then clarifies the specific research objectives and core directions, laying a solid foundation for the subsequent literature review and empirical analysis. Financial markets show nonlinear characteristics. The traditional linear VAR models fail to capture regime switching caused by sentiment, capital, and policies. This paper studies threshold effects and asymmetric cross-regime correlations. Most existing research adopts linear frameworks and rarely analyzes regime linkages of China's stock index futures basis, which is the core motivation of the study. This study selects CSI 1000 and CSI 300 stock index futures basis to analyze their nonlinear linkages. It explores their nonlinear correlation structures, identifies embedded threshold effects, and analyzes regime-dependent transmission paths. The research complements existing linear studies and offers practical guidance for cross-index derivatives trading. We have clarified the research background, core issues, and objectives, as well as the motivation and general direction of this paper. Next, we will review the existing literature to sort out research progress and limitations in this field. What fruitful outcomes have been achieved regarding stock index futures basis, and what unresolved problems remain? We will elaborate through a systematic literature review. Existing studies on stock index futures mainly develop 3 core research branches: price discovery of CSI 1000 and CSI 300 stock index futures, risk transmission mechanisms between futures and spot markets, as well as basis characteristics and arbitrage opportunities. Academic interest in China's stock index futures keeps rising, and scholars have formed 3 unified consensus findings, which build a solid foundation for follow-up relevant research. Vanguard confirms tight future spot dynamic linkages with persistent shocks and volatility clustering. Basis serves as the core channel for arbitrage and asymmetric risk redistribution when deviating from equilibrium. Quantum regressions reveal asymmetric basis movements. Shocks surge nonlinearly in high volatility, calling for nonlinear risk models. Most existing studies rely on linear frameworks, using Gauge models and Granger tests while neglecting threshold effects and regime switching in basis co-movement. This paper examines the nonlinear dynamic linkage between CSI 1000 and CSI 300 basis across different market states, supplementing relevant nonlinear research. The previous literature review identifies research limitations and clarifies this paper's focus on nonlinear basis linkage. Next, we analyze statistical characteristics of the 2 basis series to lay factual groundwork for mechanism tests. We will then discuss notable co-movement features of their fluctuations. Clarifying data scope and core variables is essential for reliable empirical results. This study adopts long-term samples covering diverse market cycles that fit the development of China's futures market. Clear variable definitions and measurement criteria are formulated to ensure rigorous subsequent analysis. Neither basis series shows an obvious long-term linear trend, proving the complexity of a share index futures markets. Both fluctuate in alternating tranquil and turbulent stages, offering preliminary evidence of regime switching. CSI 1000 basis fluctuates more wildly and frequently due to small caps' higher sensitivity to market shocks. Significant nonlinear dependence exists between the two, with correlations varying under different market conditions, which justifies nonlinear modeling. CSI 300 large cap basis stays steady and spreads risks to small caps via arbitrage. CSI 1000 small cap basis is more volatile and impacts large cap basis through cross-market arbitrage. Their volatility gaps support nonlinear analysis and form cross-market risk transmission channels. The characteristic analysis above reveals fluctuation rules and nonlinear linkage of the two basis series and points out research improvements. We then move to methodology construction, which offers a rigorous empirical framework to test regime switching and threshold effects. I will introduce the model setup and preprocessing steps in detail. This paper adopts the threshold VAR model to depict basis linkage. It uses first difference large and small cap basis as endogenous variables and small cap basis changes as the threshold variable to divide volatility regimes. The model has two merits. It captures nonlinear dynamics and threshold effects. It estimates distinct coefficient matrices across regimes to reflect asymmetric transmission. ADF unit root tests are used to check stationarity. Original CSIA is stationary, while CSIB is non-stationary. After first differencing, CSIA_D and CSIBD both pass the test, satisfying prerequisites for threshold VAR estimation and causal analysis. Three information criteria yield different optimal lags. AIC selects lag 8 for better fitting, BIC picks lag 3 with stricter penalty for complexity, and HQIC chooses lag 5 as a compromise. Given TVA estimation features, BIC offers stronger robustness against overfitting, so TVA3 is adopted for empirical analysis. We have finished model construction, stationarity tests, and optimal lag selection, forming a complete empirical framework. Next comes formal empirical analysis. Granger causality tests and TVA estimation will verify our hypothesis of nonlinear linkage between large and small cap basis. We will elaborate on test results and key findings step by step. Full sample Granger causality tests reveal significant bidirectional causality between CSIAD and CSIBD. The impact of CSIBD on CSIAD is significant at the 1% level, while the reverse holds at the 5% level. Tests separated by low volatility regimes show obvious asymmetry. Only unidirectional causality runs from CSIBD to CSIAD with no significant reverse effect, verifying nonlinear market linkage. In high volatility regimes, bidirectional Granger causality reappears between CSI futures and spot basis. The F statistic of CSIBD affecting CSIAD hits 18.36, much higher than 5.18 in low volatility periods. This proves stronger co-movement and faster cross-market risk transmission amid high volatility. Under low volatility, asymmetric spillover effects are observed. Lagged B basis positively and significantly affects a basis with coefficient 0.38, while the reverse impact of on B is only 0.05 and insignificant. Market also exhibits obvious short-term mean reversion. In stable markets, information transfers unilaterally from B to A. VAR estimates for high volatility regimes show only the second leg of CSI 300 spot has marginal significance. All cross-market lag spillovers turn insignificant, breaking the original stable transmission mechanism. In turbulent periods, market linkage shifts fundamentally from fundamental price guidance to collective sentiment. Capital correlation rises, risks resonate faster, and systemic exposure expands greatly. In stable markets, CSIB_D steadily leads CSIA_D with measurable linkage. In high volatility, cross-lag causality vanishes, and synchronous co-movement along with risk spillover intensifies sharply. To sum up, transmission direction, magnitude and duration change dynamically with obvious threshold effects, verifying asymmetric market mechanisms. Shocks to CSI_D decay immediately, turn negative at the first leg and converge oscillatively, reflecting strong short-term mean reversion. CSIAD responds to CSIB_D shocks contemporarily and gradually converges to zero, confirming stable cross-market transmission under normal conditions. Impulse response analysis confirms the unidirectional dominance of CSIB_D in low volatility regimes. Response intensity of CSIB_D to CSI_D shocks fluctuates narrowly around zero, validates the established linear leading relationship. Stable market conditions sustain clear transmission mechanisms. CSIB_D acts as the core driver. CSI_D produces predictable responses, and market efficiency is maintained through unobstructed transmission channels. In high-volatility regimes, the original cross-market transmission mechanism weakens significantly. The positive leading effect of CSIB_D on CSI_D vanishes, and its impulse response fluctuates randomly around zero. Shocks from CSI_D to CSIB_D only trigger weak short-term responses before converging to zero, with greatly reduced spillover strength and duration, which confirms structural changes in transmission. Impulse responses under high volatility show slower shock convergence and total breakdown of linear leading relations. Basis series move in tandem, with synchronous volatility replacing sequential price spillover, shifting risk transmission from linear to nonlinear patterns. This aligns with regime regression outcomes. Steady markets feature unidirectional spillover from CSIB_D to CSIAD, while linear linkages collapse amid turmoil. The clear movement of basis spreads is thus double verified. We have completed impulse response analysis of the two basis series under low and high volatility regimes, and identified heterogeneous cross-market transmission mechanisms across market conditions. Next, we move to the conclusion and policy recommendation section. We will summarize core empirical findings and propose targeted strategies for different market participants to support practical applications. This paper investigates the nonlinear linkage to basis spreads and draws three main conclusions. First, their spillover shows clear regime asymmetry. CSIB_D unilaterally drives CSI_D in stable markets. Second, linear transmission weakens under extreme volatility. Both spaces fluctuate synchronously with stronger risk co-movement. Third, spillover characteristics change across regimes, confirming significant threshold effects. In stable markets, CSIB_D unilaterally leads CSI_D. Investors can develop cross-spread arbitrage strategies, use hedging tools, and optimize position management based on the spillover rule. In high volatility regimes, linear linkages disappear and basis spreads co-move strongly with rising cross-market risks. Investors should cut leverage, shorten holding periods, and adjust risk control frameworks to guard against synchronous risk shocks. Regulators should establish differentiated monitoring and regime-based risk warning systems. In stable markets, compliant arbitrage shall be encouraged to improve pricing efficiency. In turbulent periods, stricter supervision is required to curb cross-market risk contagion. Regulatory policies shall account for regime asymmetry and threshold effects of basis dynamics, implementing state-specific supervision to stabilize spot futures markets and boost transparency and operational efficiency. This study only analyzes dynamic linkages between two basis spreads, leaving room for further expansion. Methodologically, exogenous factors such as liquidity and policy shocks can be incorporated. Multi-threshold and advanced nonlinear models may deepen the analysis. In scope, the research can be extended to other stock index futures, explore macroeconomic impacts on basis spreads, and build real-time regime monitoring systems to enrich cross-market risk research. Dear colleagues, thanks for your attention. This study examines the nonlinear linkage between two basis spreads. Stable markets have unidirectional spillover, while high volatility triggers synchronous swings, supporting differentiated regulation. Our findings benefit investors and regulators. We will expand relevant factors and models in future research. Thank you and look forward to further discussions.